Alright, good evening everybody. Okay, welcome to the new topic of waves. Okay, in this segment here, we will look at a different section of waves. The first section we look at, we will be looking at the introduction of wave, whereby we will run through the basic understanding of waves and the basic types of waves that are in the O-level syllabus. After that, we will look at the properties of wave motion in terms of graphical representations. What are the how do we interpret the graph of different wave motion, and what are the information that we can actually decipher from the wave graph itself. Now, firstly is, what do we mean by what is wave? What do we understand by wave? Wave in general is, we can classify it as a disturbance. Okay, it's a disturbance, but this disturbance is unique in the sense that it actually transfers energy from one place to another place, but the appearance look like it's moving, but what it actually does is it only transfer energy from one location to another location, but the particles, the air particles or the water molecules, they are involved. They are actually only vibrating at their fixed locations, whereby the particles take on different position at different timing. They will form a new wave and this different design or this different setup of wave motion actually allows energy to be transferred from one location to another location. Okay, we will be looking at wave motion, or we can actually take wave motion as a repetitive motion, whereby a particular frequency or a particular design is actually repeated and repeated and repeated and repeated, and in this series of repetitive motion, and this is what we call a wave motion. Okay, we will look in detail what do we mean by repetitive motion, and we will look at what do we mean by movement of energy without the movement of particles. Okay, we will look in detail in the next few slides. But before we move on, one of the important things that we need to really understand is what we mean by repetitive motion, or what we call periodic motion. Okay, periodic motion is what we know as a regular motion being repeated at regular intervals, which means that this particular design or this particular pattern is actually repeated at regular intervals. For example, the swinging of a pendulum, okay, from it left, right, A, B, all these locations, all this movement, the fact that it moves from A, B, and back to A is what we call a one oscillations. And what does this represent? It means that this one oscillation or this motion is actually repeated for the next few cycles. For example, it will be from A, B, and A, and after that the motion will repeat A, B, and A, B, and A. So you find that this motion is actually repeated, and this is what we call a repetitive motion, or we call this a periodic motion. Now, waves in ropes, there are different designs. They can actually represent wave in various formats. One of the common one is waves in ropes, or we actually can represent waves in water. Okay, water waves. But both, regardless of the representation, the common or the concept or the common things between them is still the same. You'll find that if I'm going to swing the wave up, the rope up and down, okay, I'm going to go through a series of motion of just swinging the rope up and down. You'll find that while I'm swinging the rope up and down, the rope, different segment of the rope will be moving together with me. Okay, while the arm is moving up and down, you'll find that the particle P will be moving up, then after that down in the next few cycles. Okay, when P is moving, you'll find that Q will start to move. Okay, particle Q will start to move in series. After P already, then the particle Q will start to move, and they will again exhibit the same motion of up and down. Particle P will be actually exhibiting the same motion of up and down. And if you look from far, you'll find that the whole, while I continue to swing, while PQ continue to move up and down, other parts of the rope will also be executing the same motion, and you'll find that the whole wave will actually be moving from left to right. But surprisingly, if you just focus on the particle itself, you'll find that P and Q will only be moving in a particular direction, which is up and down. Okay, and in this way of moving up and down, whereby the particles are moving up and down in sequence in the periodic motion in a regular intervals, you find that the energy eventually will be transferred from one end to the other end. Okay, but the particles will actually remains at the same location, exhibiting the only regular motion of up and down. Okay, what we are seeing here in a short 5-second slides is where we want to highlight a few things. Is whereby we actually are looking at, for wave, you are looking at it as a disturbance, and this disturbance actually come from oscillators or vibrations. Okay, and what does the wave does? What does the wave do? Okay, eventually this wave, what it does is it actually transfer energy from one place to another. Okay, and surprisingly, that while doing the transfer, you'll find that actually the medium actually remains where it is. The medium actually doesn't move, even though the energy has been moved from one location to another location. We'll look in detail what do we mean by particle not moving, but yet the energy get transferred. Okay, we'll look in detail. I have two animations that you can see. We might draw a clearer picture. Now, there are two wave motion we can usually classify them. One is one will be transverse wave and one will be longitudinal waves. There are two different categories of waves, but they are still under the umbrella of waves, whereby they still exhibit the same motion of transferring energy, okay, while the particles remains at its fixed location. The only things that set them apart is the type of vibration the particle actually do. Okay, for transverse wave, you find that while I'm swinging up and down, the hand is moving up and down. While I'm moving up and down, you'll find that my wave is still moving, will eventually be moving from left to right. But surprisingly, if you look at the particle at itself, the particle at each location, you'll find that the particle will be moving only at regular interval of moving up and down, while the wave move left to right. Okay, and this is what we call a perpendicular motion, whereby the particles are moving in perpendicular to the direction of wave motion. Okay, and this will be a classic example of what we know as transverse waves. Now, longitudinal will be the reverse, or it will be the other segment whereby the particle actually move left and right, while the wave moves in the left-right motion. So what we have now is that the movement of the particle, for example, the spring. If I move the spring, I pull the spring left and right, you'll find that the particles, or what we call the wave segment here, will only be moving at a regular motion of left and right also. So while the wave is moving from left to right, you'll find that the particle will also be moving from left to right. And this is what we call the wave travel, and the direction of vibration of medium particle is actually parallel to each other. Okay, now before it might be a bit confusing, so that's why I prepared two animations for you to look at what we mean by transverse wave, whereby the particles are moving perpendicularly to the wave motion, and another animations whereby it will depict longitudinal wave, whereby the particles will vibrate left and right parallel to the wave motion, which is left to right also. Okay, now let's take a look. What you see here is an animation by Chpt by Field. Okay, it's a very good classic examples of wave, transverse wave. What you see here is a slinky is a transverse wave moving up and down by the oscillator here. Okay, the frequency, like I said it, how big or how high, how intense it is vibrating. Okay, this is where I set it here. Okay, now I set it to vibrate at a certain frequency, at a certain rate. What you see that in a nutshell, you'll find that the wave is moving from left to right out of the window. Okay, you can see there is clearly a description, or there's clearly a motion from left to right. But if you look at the particle, for example, let's take a ruler and let's place it at this green color dot here. Okay, so we look at this green color dot here. You find that while the wave is moving from left to right, the green color particle is only doing a regular fixed motion, which is up and down. So you find that while as a whole, the wave is moving from left to right out of the window, the particles are only moving up and down. And they are not, and it's always the same particle. While the wave moves from left to right, energy gets transferred from left to right. The same particle is always at its fixed location. Okay, the green particle, take a look, is always there. What they only do is it will be vibrating at its own location. And what vibrating are we looking at? Is vibrating up and down. Okay, while the wave is moving from left to right. So this is what we mean by the vibration is perpendicular to the wave motion. And we classify this type of wave motion as transverse wave. Now, for longitudinal wave, I have a good simulation here by physics classroom. Okay, now this animation shows how the air particle move. Okay, when the sound passes through. The green color dot that you see here and the red color dot, they are all air particles along I would say a tunnel here. And you see the dotted blue line here depicts the wave motion. So the waves that's going to the wave that we are looking at is a sound wave, is a longitudinal waves. Okay, its frequency, speed, and amplitude, I have set it, I have calibrated it. So what we are looking now is this: how will it look like when the waves move from left to right? Now, the dotted line you see is moving. The dotted line describe or depict the movement of the sound wave itself. Is moving from left to right. But if you look at the vibration of the air particles, the green color and the red color one, okay, they are moving about, okay, left and right. And if you focus at the air particles, you'll find that they are actually exhibiting a motion that is actually parallel to the sound travel of the sound. And let's look at a few of the particles. Let's look at the one in red. Okay, let's look at your right side, bottom right, the red color dot here. Okay, the red color dot here. Okay, this is one of the air particles, and you see that as the wave moves from left to right, this air particle is only doing one repetitive motion. It is just vibrating left, right, left, right. If we take the blue line as a center line, you'll find that the red color dot, the red color air particle, is only vibrating left to right about the blue dot. It's only left and right only. Okay, it's moving left to right because the sound wave just passes through, and as a result there will be some motion, there will be some movement. Okay, the air particles will be taking up different position to actually form up the wave and to encourage and to actually allows energy to be transferred by the sound particles from the left to the right. But while this is being transferred, while the wave is being moving from left to right, you'll find that the air particles are only vibrating left to right. It's not even moving, it's always vibrating at its fixed position. And this type of wave motion is what we term as longitudinal waves. Okay, I hope the animation that I have here will actually shed some light towards you understanding or you differentiating what's the difference between transverse wave versus longitudinal wave, and also to shed some understanding of what we mean by transfer energy without the medium moving. Okay, so this is the two highlights that we have for this particular section, okay, whereby we look at transfer energy without the medium moving, and what we know, how do we differentiate transverse waves from longitudinal wave. Okay, these are two things that you have to be clear or you have to understand. Okay, if you have any doubts or it's still a bit confusing, feel free to rewind the video and look at it at your own pace, or you can even visit the website, the animations, to get a clearer understanding. Okay, if not, thank you for watching. See you.